Hi, everyone. Today I want to explain about deadlock avoidance that might happen in your device. So let's begin. What deadlock avoidance mean? Deadlock avoidance means the operating system tries to stop deadlocks before happening. Next, how can an OS avoid the deadlock? Here is how OS avoid from happening by knowing the maximum resources that need. OS also knows the free resources at that time, and then before allow any processes our CPU will check first either safe or not to proceed. For example, imagine a hospital full of patients arriving at same time. Some need surgery, checkups, others are in emergencies. In this story, each patient is like a computer process, asking to use the system's resources. The doctors and nurses are like the CPU and memory. They're the ones doing the work by treating patients, running operations, and keeping everything moving. Treatment rooms? They're input and output devices, that limited in number and shared by all. If two patients try to use the same room at the same time, we've got a problem. This is where the operating system comes in. Just like a hospital manager, it organizes the patient queue in deciding who gets treated next and then handles memory, making sure no two patients fight for the same bed. It even logs medical records, so patient info is stored and easy to find just like the file system. When an emergency happens like a patient fainting, the system pauses normal tasks to respond immediately. That's called interrupt handling in computer terms. That is how the OS plays a role in managing the CPU and memory, controls input and output devices, organizes data storage, and arranges data to keep everything running smoothly and efficiently. Now imagine this hospital without a manager. No queues, no room assignments, records missing, doctors overwhelmed. That's a computer without an OS, stuck and inefficient. If resources aren't managed smartly, we get a deadlock when everyone waits forever and nothing moves. So from this story we can imagine that OS uses deadlock avoidance for making sure resources are only given out when it's safe so no one's will stuck. Let's continue. How to determine safe state. IN Banker's algorithm. There are four main components in the calculation algorithm. First, claim matrix shows the maximum resources. Second, allocation matrix shows how many resources have been given to each process. Third, how many more resources each process needs to complete. Lastly, available vector shows the remaining resources. Resource matrix refers to the total system resources. If resources increase, the system may change from unsafe to safe because more processes can be supported. If resources less than claim, the system will test first before granting resources. If the system remains safe, then the resources will be granted. If not, the processes have to wait. Before we start any process, we need to look at the resources needed first. Here, the second process is started first because the resources needed are smaller compared to the available resources. Then, P2 runs to completion with the condition allocate matrix plus available vector. Then, we repeat the same process with check need matrix. After that, P1 runs to completion. Lastly, we repeat the same process and update available by adding allocation of process 3. Then, repeat the process for the next steps. How to determine unsafe state. From this initial state, the system will begin to evaluate. Are there any processes that can be run with the available resources? When P1 runs to completion, there no one process has need less than or equal to available from the initial state and the system is in an unsafe state. Lastly is advantage and disadvantage of deadlock avoidance. First advantage, it is not necessary to preempt and rollback processes, as in deadlock detection. Second, it is less restrictive than deadlock prevention. And then for disadvantage, processes are independent with no synchronization. And processes cannot terminate while holding resources.